Hello dear students, welcome to Saiva, the new session of class 10 physics. So in the last class we have discussed about the atmospheric refraction and some optical phenomena related to atmospheric refraction. And today again we want to discuss about the optical phenomena related to atmospheric refraction. And the next one is that star appears higher. Star appears higher. Clear? So you just listen here. Consider a star is at the position X and the same star is at the position Y. One person is observing from this position from Earth. He or she is observing from Earth. Yes. So this is a pictorial representation of the phenomena or the point. So here at the position X, one star is there and this position is called actual position. Actual position. The position Y, the same star, the position Y is called apparent position. Apparent position. Okay. Clear? So actually when we observe the star from Earth, it seems to be appear higher than they actually are. What is the reason behind this phenomenon? So we know that the atmosphere, different layers are there, and we have already discussed in the previous class, and each layer has its own optical density. And the upper atmosphere is what we call the hotter region, and the lower atmosphere or the atmospheric layer that just near to the surface of Earth is colder in nature, right? So the upper atmosphere is hotter and the lower atmosphere is colder. Or the upper atmosphere is optically rarer medium, the lower atmosphere is optically denser medium. So we already discussed all these points. And because of the same reason, the things are happening like this. Here, the upper atmosphere is optically rarer medium because comparatively warmer region, and near the surface of Earth, the air layer is comparatively colder because optically denser region. Clear? So when the starlight, and also the star has its own ability to produce light, that is called starlight. The starlight is traveling through different atmospheric layers like this. Different atmospheric layers are there and this light is continuously traveling through this atmospheric layers of different optical density. So we know that each layer has its own optical density. So whenever the light is passing through different media, the refraction of light takes place. Right? The same process is happening here. The starlight is passing through different media or different atmospheric layers having different optical density. As a result, the starlight is bending. Right? And when this starlight is entering through this atmospheric layers, atmospheric refraction takes place. As a result of atmospheric refraction, the person those who are standing on Earth happen to see that the star is just higher than the actual position. So actually X is the actual position, but the person is seeing that the star is at Y, means slightly higher than that of the actual position. So this position X is called the actual position and the position Y is called apparent position. So we are always seeing that the star is slightly higher than the actual position. Clear? One more important thing is that while coming down, the optical density is increasing. Because we know that the upper atmosphere is hotter, therefore the upper atmosphere or the upper layers are called optically rarer medium. While coming down, the optical density is increasing. Optical density is increasing. Optical density is increasing. Clear? So these are the points regarding the position of star. So here you just remember that the star is at the position X and the same star appears to be higher than its actual position, that is Y. So whenever a person is observing the star from the surface of Earth, he or she happen to see that the star is slightly higher than that of the actual position. The actual position is at X, but he or she is seeing that the star is at the position Y. That position is called apparent position. And this phenomenon is due to the atmospheric refraction. Atmospheric refraction means the refraction that takes place in the atmosphere. Means atmosphere consists of different layers and each layer has its own optical density, right? The upper atmosphere is optically rarer. While coming down, the optical density is increasing. Optical density is increasing, and the lower atmosphere or the atmosphere just near to the surface of Earth is optically denser medium. So the light bending like this, or the refraction of light takes place. As a result, the person happens to see that the star is slightly higher than that of the actual position. Clear? And is about the position of star in the night sky. Clear? And it is one of the applications of, or one of the important points of the atmospheric refraction. One of the important optical phenomena related to atmospheric refraction. Clear? Okay.